What's up, everyone? My name is Dr. Chris Hacks, and welcome back to our CryptoPals Crypto Challenge series. Today we're going to be doing challenge number 5, implementing a repeating key XOR function. Now, if you remember back, in challenge 3 we implemented a fixed key XOR function. This is going to be almost identical. It's very similar with one very minor change to the function. So let's first read the problem statement. So we got this string here from a very important opening stanza. Burning them, if you ain't quick and nimble, I go crazy when I hear a cymbal. Very nice. So we're going to encrypt it with the key ice. And the way we're going to do this is it's going to rotate through the key. So the B is going to be XORed with the I. The U will be XORed with the C. The R will be XORed with the E. And then the N will be XORed with the I. And it'll just rotate like that. And then it should output this answer right here once we hex encode our final string. So let's jump right in the code and we will take a look at what we're doing. So I got this encoding utils header right here. Let's go ahead and add our function. So string, and we'll call it repeating XOR. So we'll have two strings. We'll have a const string input. Let me get a reference. Input. A const string reference key. Perfect. So I can just go ahead and copy this and paste it here. And here's how similar it is. So we don't need to validate the size. Like in the fixed XOR, both strings have to be the same size. Or with the key, they don't. So all we have to do is, let's first I'm going to create two variables. I'm going to hold the size of both of our strings, just so we have them in like cache memory in the CPU, so it's a little quicker. The compiler would optimize this anyways, but I'm just going to hold it like this, just in case. So we'll have input size equals input.size, and then key size equals key.size. I don't know if you all had to do this, but in my CS classes, we would always have to do stuff like this rather than calling it in a loop. So like, for example, we're going to call this key size in a loop. We would just do it like this, and for some reason that was expected. Like I said, most modern compilers will optimize this away, but we'll just add it anyways. Okay, let's put a string called output, and what we will do is we will do output.reserve. So we're going to make sure this string has enough size, enough space, and it is going to be the exact same size as the input, because well, our output is just going to be the input string XORed with the key. Okay, and then what we'll do now is we'll make a pointer called p. So it's just going to be iterating over our string and telling us which characters we're XORing together. So with that, I will do while p is less than input size, and that will make sure our while loop continues correctly. And then actually, you know what, we can just use a for loop for this. What am I doing? We should just use a for loop. That's the correct way to do this. Both will work, but for loop is a little bit more correct, just because we're going to be incrementing p anyways. Okay, so we got our for loop here, and then what we will do is we will start outputting, or doing our XOR. So output.pushback, and we will have input p, iterating over that, XORed with key p, and then we do have to do this modulus operator. It is a little bit expensive because it is in a loop, but we will modulus p with key size. That way we will be able to loop through it. So like, say for example, p is 4 and the key size is 3, it'll loop back around and we'll get the correct characters. Okay, and then we can just go ahead and return output. So the nice thing about this function, it works with the fixed OR. Like if you were to pass a fixed OR two strings that were the same size into this function, it would work exactly the same. This just has the added benefit of allowing strings that don't have the same length. Now we're going to keep this here. If you guys want to get rid of it, you totally fine. That will work. We will not be using a fixed OR later on. Everything else from here on out will be the repeated OR. But like I said, repeated OR will work with the fixed OR plus with strings that are not the same size. Okay, so with that all said and done, we can go back to our challenge 5. I already have the 2 strings here. I have the string for the stanza, and it has a new line symbol. This is important. Make sure to include this. And then it also has the key. So all we have to do is std string, call it plain text, and that is just going to be, or not plain text, we're going to get ciphertext. And that is just going to be the repeating XOR, and we will have our plain text and our key. Okay, and then we can just text to hex our ciphertext, and that should give us our correct output. So now let's go ahead and run this, and we will see, compiling everything. Okay, and that looks correct. Yeah, pull that back up. Yeah, 0B3637, yep, and ends with the same, so there we go. So that's all there is to it. Very plain and simple. It's very similar to challenge 3, just a slight tweak to it. So thank you all for watching. Make sure to tune in next time for the challenge number 6, which is going to be a much harder challenge with a lot more complexities and nuances to it, but we'll go over all of that later. But thank you all for watching, and I look forward to seeing you all in the next video.